Okay, so you've already seen the dot product formula. So A dot B is equal to the modulus of A times the modulus of B cos theta. And we can rearrange that to work out cos theta. So just taking the modulus of A and the modulus of B underneath. So we've got A dot B over modulus of A, modulus of B. Okay, that will obviously then allow us to work out the angle between two lines, okay, between A and B in this case. Now, sometimes you'll be asked to calculate the acute angle, okay? If you think about it, if you've got two lines crossing, when you've got two lines crossing, you've got one angle would be an acute angle, and one angle would be an obtuse angle, okay? And when we work out this, depending on what the calculations are, will depend on the angle we're given. Now we could obviously do 180, take away the angle, because they're clearly going to lie on straight lines and we've got two lines crossing. But we can actually make a slight adaptation to this, which if you've seen the PowerPoint is already on there. And that's by taking the modulus of it. So if we take cos theta is equal to the modulus of A dot B over the modulus of A times the modulus of B, then that will allow us to find, this will always give the acute angle between the two lines. Okay, so it's just a slight adaptation that we can make that allows us to then find the angle between two lines. Okay, so if we take an example, and I'm going to do the examples that are on the PowerPoint and just talk you through them so that you've got my explanation to go with it as well. So the first example on the PowerPoint is the lines L1 and L2 have vector equations R equals 2i plus j plus k plus t 3i minus 8j minus k. Now obviously we'd normally use lambda and mu, they've just used t and s, but it doesn't matter, it's the same thing. And then we've got r, the other one, line 2 is 7i plus 4j, oh that's a 4, 4j plus k plus s, 2i plus 2j plus 3k respectively. Okay, and then we're told that given that line 1 and line 2 intersect, find the size of the acute angle between the lines. Okay, so from the equations of the lines, you should be happy that A and B are the direction vectors. Okay, remember this is a point that it goes through, this is your direction vectors. So using the direction vectors, we'd have A equals 3i minus 8j minus k, and B is going to be your 2i plus 2j plus 3k. Okay, so from that we can then work out A dot B. So A dot B is going to be equal to your 3 times 2, remember it's your coefficients of I, add your minus 8 times 2, coefficients of j, add your minus 1 times 3, coefficients of k. So we've got 6 minus 16 minus 3, and that's going to give us minus 13. Okay, and then we can work out the modulus of each of those. So the modulus of A is using Pythag, so it's going to be 3 squared plus minus 8 squared plus minus 1 squared. Okay, just put it into your calculator, you get root 74. Modulus of B is the square root of 2 squared plus 2 squared plus 3 squared, which is root 17. And then we can just put it straight back into this formula here to work out the acute angle. Okay, so we've got cos theta is equal to the modulus of A dot B, so minus 13, over the modulus of A times the modulus of B. Okay, and you can put that into your calculator. I'd suggest you take the cos over as well and do cos to the minus 1 of that and do it all in one go. And that should give you, to one decimal place, 68.5 degrees.